So, the question from the end of the last video, when does a limit not exist? There's lots of ways for a limit not to exist. The first way is, remember I said that the function has to go to one point from both sides. Not all functions do, as we know, right? There's a famous one, the Heaviside step function, right? 0 for x less than 0 and 1 for x greater than or equal to 0. Named after Oliver, I think, Heaviside. Anyway, used to model an electric switch, right? There's no, this is like here, right? There's no current going through until you flip the switch, and then there's current going through. Okay, so you can see how this is a, hopefully you can see that that's an open circle down there. I'm going to see open circle here and a closed circle up there. Okay, so this is one where it's not showing up very well as far as I can tell on the video, but I've got all this here. Okay. Hopefully that's good enough. Anyway, a very natural function, a natural step for a real reason. But if I look at this, I can't give one number to what's going on at x equals 0, because from one side it's going to 0, and from the other side it's going to out. So if I say, what about the limit as x goes to 0 of h of x, I can see immediately the problem. It goes to 0 on the left, and it goes to 1 on the right. Which one do I choose? I can choose neither of them. So therefore, the limit doesn't exist. Okay? Now, it's only at 0 that I have this problem, because in fact you can see it's only at 0 that I have the jump. If I ask what's going on at 1 or at -2, it's no problem because the function is just constant there. So I can write the limit as x goes to 1 of h of x, right? And I'm going to look at 1 and I can see it's just going to 1. Or I can write the limit as x goes to -2 of h of x. And I see what's going on at -2. It's clearly 0. Right? It's going to 0 from both sides. So those are not a problem. My problem is coming from this jump. Okay? Of course, we still made some good observations about the behavior of h of x near 0. Precisely, we want to point out we have that jump there. And in fact, that's the reason we're using this function. We're using this function because it has that jump. So although the full limit, the both-sided limit doesn't exist, it's certainly going to 0 on the left and going to 1 on the right. So we do want to have some vocabulary in order to say that. So for a problem or for a situation like this, we will use the vocabulary of one-sided limits. Okay. So let me, so even though the full limit doesn't exist, we can talk about the left-hand limit and the right-hand limit. Okay, so let me define that nicely. So I can give you the lingo. What we do is we put in. Actually, I don't know why I got rid of that, so I can look at it when I'm talking about it. So it's almost the same notation, but there's a little minus up here. Okay? It's just like a little minus up there, and that means from the left, basically you can think of it meaning at the point minus a small amount. Okay? So means, so what this means is that as I approach A, as x gets very near A, but is less than A, the value of f of x gets very close to L. And in this case, of course, it is L because they're all 0, right? So in this case, for the Heaviside step function, I would write this as limit as x goes to 0 from the left of h of x equals 0. And from the right, it's going to be the same definition. There's going to be a plus here because it's your a plus a small amount. And you're only going to be looking for the right-hand limit of values of x that are bigger than your a. So that would look like this. So it's basically the same definition. And I could have written it a little bit smaller. I had to munch it in there. Okay, so then for our example of the Heaviside step function, we would write the limit as x goes to 0 plus of h of x equals 1. Okay. Nevertheless, the full limit doesn't exist because it is not the same from both sides. So for that, I write it in math like this. And I can just put dne for does not exist. And you can also put dne like that into WebAssign, and it says that, or write dne if it doesn't exist. So that's fairly standard. Okay. And in fact, what I wrote here, we can write down as a property. Okay. So what I mean to say is that the limit as x goes to A from both sides equals L if and only if each limit from either side also equals L. So the limit from the left and the limit from, well, the space there, I'll write it here, and the limit from the right. And I used to always forget whether the minus or the plus or left or right until I remembered. I can just think of it as a minus something small, epsilon, delta, whatever, or a plus something small, even delta x, a plus delta x or a minus delta x, something small. So that's the idea there. Now, let me do a quick example, and then I'll come back with another video showing some other ways for a limit to not exist. So for my quick example, what I wanted to do was draw a one, two, three, 1, 2, 3, 1, 2, 3. Okay, so I'm just trying to make, maybe I could have made that a little bigger so you guys can see it better, right? 1, 2, 3. Does that looks a little bit more right? Here, -1. Okay, so here's just some kind of random function that I just made up. I'm just defining it graphically. I am not giving you a formula. And we're just going to kind of fill in. The function is named f of x, of course. We're just kind of going to fill in some of these properties. Well, we'll just start with -1. I have like 10 of these, but let's just start with this. Okay, so if you look at what's going on at -1, we can kind of see, as I'm on the left-hand side of -1, if I go on my line, it looks like I'm heading towards the point at 2. On the right-hand side of -1, I'm heading towards the point at 1. The actual value is going to be where the closed circle is, so that's going to be 1. And the full limit, of course, does not exist because these two are different values. I can see I've got that nice little jump there. All right, now let's see what happens at +1. So I'm so lazy. Look at that. Ah. All right, the negatives are gone, and now we're back to the positives. Oh, I need that negative, right? Because I want to see what's going on from f of x, left and right. But here now on the other side of the axis on +1, as I'm going from the left, of course, I'm going to this, which is also going to be 2. And I'm also going to 2 on the right. So this is a similar picture to the very first example that we had. It's just that instead of just erasing a point, essentially, this would be this kind of situation where if I had to write down a function that does this, I would have to, like, if I had to write down the formula for it, it would be a piecewise defined function as well, and it would just be different, like this whatever would be that would be that, whatever. They're whatever they are. We can make them up, parabolas, whatever, but we don't have to. The fact that it doesn't extend doesn't matter. It just matters that they're both basically going to the same place, as you can see. And now f of 1, I've got my -1. But because both the left-hand limit and the right-hand limit are going to the same place, then that is a full limit is 2. Okay? Let's see. Last one. Okay, and I'm going to have to do the last one. I can do other ones, right? We can do it for, let's do 2 now. Okay, well, 2 is kind of not terribly interesting, right? Because 2 is just a nice continuous function through 0, right? So it's going from the left, it's going to 0, from the right, it's going to 0, the value is 0, and the limit is 0. So I know a lot of the times in this class we are interested in the weird points where something's going here, which way, or that, but we can talk about limits at any point. But it's just that that's why we don't do this kind of one very often. Now if I look at 3, that's my other option this here. 3s, switching it all out to 3s. Okay, so this is a situation where I do have an open circle, but as you can see from both sides, it's still going to the point where y equals 0. So these are 0. So that one's going to tell me this limit is equal to 0. But I don't have a value. Nobody gave me a value for f of 3. So f of 3 does not exist. So if I were to be asked for the domain of this function, I would say the domain was all x except for x equals 3. Because the assumption is that whatever this is doing, it's going to keep doing on the other part of the domain, unless it was cut off for some reason.